This short video can be used to practice adding and place value as you think about it conceptually and procedurally. Pause the video when you have problems to do, and then continue to see if your ideas match the ideas that are included in the video. This video includes think aloud language so that students and teachers can think conceptually and procedurally after working with manipulatives and pictures. Remember that it's very important for students to see the math first with real objects, real things, place value blocks, objects, drawing pictures, putting bundles together. All of that work should come before what's happening in this video. Complete these two problems using the conceptual idea of place value to add. Remember that there are a variety of ways that this can be done. Then check your answer when you're ready to move on. Also notice the word at the bottom with the question mark, carry. Let's talk about that word in a minute. If I were doing these problems conceptually with place value, I would start with the largest place. I would start in this problem with the tens. The reason for that is because it helps me with mental math. I can think 4 tens plus 2 tens is 6 tens or 60, so my answer is going to be close to that before I even go on. I also know that 5 ones and 3 ones is 8 ones. If I add them together, I get 68. If I move to this problem, I can see that I have 3 hundreds plus 8 hundreds, which is 11 hundreds. And we want students to be able to think about that, 11 hundreds. We know that our answer needs to be about 11 hundreds or a bit more than 1,000. It helps us estimate. Then I can go to 4 tens plus 2 tens is 6 tens or 60. 8 plus 9 is 17. Those are the ones. And I can add them all together to get my answer. Remember also that I can do this in any order I want. If I decided to start with the ones place on this problem or the tens place on this problem, I can do that. But by starting with the largest number, we're thinking mental math. Right off the bat, we're thinking that my answer should be about 11 hundreds or a bit more than 1,000. You'll notice on this slide that I did not talk about the word carry. That's because we didn't have to carry as we did this. This is one of the reasons that this is very good for students. There are 2 reasons I really like this way of adding. One, students have to think about the value of every digit. They're not thinking about just a 4. They're thinking about it as a 4 tens or a 40. They're not thinking about just a 3. They're thinking 3 hundreds. They're not thinking about just a 2. They're thinking about 20 or 2 tens. They're thinking about the value. The other good thing about this method is that there is no carrying, and for many students carrying is confusing. It's easier for them to do their adding this way, and we'll talk about the carrying in just a second. You just completed 2 problems using the conceptual language of place value. Now let's go to the procedural methods, the methods that are traditionally taught in schools. These are the shortcuts because there's less writing. Sometimes I'm not sure they are shortcuts in thinking, but they are shortcuts in writing. Complete these 2 problems in the traditional method of adding, and use language as you do this to try to get at the value of the numbers, even though you're not using the place value method of adding. Let's see what you do. If I were adding these in a traditional sense, I would be thinking this, and I would ask my students to speak aloud sometimes when they do these problems so I can hear their thinking. 3 ones and 2 ones is 5 ones. 7 tens and 3 tens is 10 tens. I already have a number in the ones place, so my answer is 105. If I go over to this problem, 3 ones and 8 ones is 11 ones. I usually teach my students to put the tens up here first before they put the number here so that they don't have to think backwards. And then when we put this number at the top in red, I don't use the word carry, at least not right away. What I say is I'm going to put this here because this is a 10, so it has to be with the tens. Now I have my tens all together. 1 and 5 is 6. Plus 7 is 13 tens. 13 tens is made out of 100 and 3 tens. So I had to put the 1 with the hundreds because that's where it belongs. We can only add like things. Now I have 1, 4, and 2 hundreds. If I add those all together, I get 700. So my answer is 731. The word carry is not exactly wrong to use in these kind of problems, but it doesn't convey any meaning. So what I like to do in these kind of problems in my own modeling, and when I hear students explain their thinking, is to be able to say, I'm putting this one here because it's a 10, and I have to add all like things. I'm putting this number here because it's 100, and I can only add like things, so it needs to be with the hundreds place. Once students have really mastered addition in the traditional method, and they're very confident about their adding, then I'm really okay if they use the word carrying. But occasionally, even then, I will ask them, why did you put that number there? Why did you put this number here? I want them to understand the reason for that. I want them to be able to say, because it's 100 and I can only add like things. Another skill related to place value is writing large numbers. And in our instructional video on this, we talked about teaching students to write first what they hear and then to go back and add to complete the number so that they can understand the place values within each family and the families that we have as we write large numbers. Take a look at this large number written out in words and write it in those two ways. First, write what you hear. Then go back and make any additions that you have to make based on what you understand about place value and writing large numbers. Pause the video and start it again once you've done those two things. So when I read this, here's what I hear. 132 billion. 132. I know that billion is the name of a family, so that means it has to be a comma. 600 million. The number I hear is 600. I know that million is the name of a family, so that has to be a comma. 45,000. 45,000 is the name of a family, so that has to be a comma. 11. I hear the number 11. Now I go back because I know that every family has 3 family members, and they all have to be represented somehow. But I need to represent them all in ways that won't change what the number says. So I have 132 billion, that's fine. 600 million, I have 3 family members and the name. 45,000. I need that to say 45, but I'm missing a family member. I can put the 0 here and it will still say 45, and now I have all 3 of my family members. Lastly, 11. I have 11 right here, but I'm missing a family member. I need to put my 0 here to make sure it still says 11. Now my number reads 132 billion 600 million 45,011. Many students will have to continue to use 2 steps in the process of writing large numbers. First writing what they hear, and then going back to see if anything needs to be added. But many students will be ready, after they've practiced that quite a bit, to just go into writing it all at one time and thinking of those 2 steps together. So if I have that same number, I can write it as I think it or as I read it. 132 billion 600 million 45,011. If I hear another large number, I may write it like this. 12,006,203. 12,006,203. So students get used to the idea of 3 family members, zeros representing family members that aren't there, family names being represented with the commas, and they can begin to write what they hear, both steps at one time.